Everything looks like it's pretty solid all the way down into the corners inside here. What's going on? We're back at it again, working on the rear end of the Miata. We're going to be finishing up the work today on the differential and getting the new bushings that just came in into the upper control arms so we can get those back in the car and get this thing slammed back on the ground. When I bought this car 3 years ago, I didn't have the YouTube channel started yet. I welded this diff without any video or any footage at all. It's been 3 years since I had this thing apart. We're gonna tear into it today and take a look at 3 years of drifting abuse on a welded differential. Now, there's a few different options for differentials for any drift car. You can try drifting it just with an open diff, see how that works for you. Sometimes it works, sometimes it doesn't. Then you can take that open diff and you can weld that, which is probably the most common thing to do with an open diff. And then both of your tires can spin together all the time. That's on acceleration and deceleration. That's what this differential is. Then you get into LSDs or limited slip differentials where they have a little bit of give side to side, but for the most part, both tires spin all the time when you're on throttle. Then you can get into the 1.5 ways and the 2 ways. I'm not real familiar with how those work, but I know the 1.5 way is fully locked on acceleration and half open on decel, which can have many different benefits. A 2-way is basically locked all the time, just like a welded diff, but has a little bit of give in between acceleration and decel. So there's different types of scenarios that you'd want something like that. I went the easiest and cheapest way for myself, which was just taking the open diff and welding it basically solid. I put 2 1/4-inch plates in there and welded all the way around the gears. You're gonna see that in just a minute. We're gonna pop this open and give it a good inspection. Now, if you're doing something with your differential, you obviously need to have it out of the car. Some vehicles, you don't actually have to have it out of the car. You can access the rear portion of the differential just right inside the car. The Miata, you do need to remove it because it's basically this one solid wishbone piece. All the bolts are accessed from the front side, and it's kind of hard to do that when it's in the subframe. So in a normal scenario, you would need a 12mm socket with an extension or a wrench or something like that. I switched out basically all of these bolts. It is still a metric thread, but the head of the bolt is no longer a 12. It is actually a 1/2 inch, which, why did I choose to do that? They needed to be replaced, and that's what was available at the hardware store. So normally it would be a 12. Most of them now are 1/2 inch. You'll also need a dead blow or hammer. You'll also need a chisel, not a screwdriver. A chisel is less likely to gouge and chip and scratch into your aluminum housing. You want to keep this nice and flat when you split this apart. You don't want to gouge that, otherwise it's not going to seal properly and you're going to have leaking issues. Once you get all the bolts loosened up, you can then pry on it a little bit, hammer it to try and pop it off. This does not have a gasket that goes in here. You have to use silicone. I just used like a red high temp silicone. It's lasted me 3 years and I haven't had any leaking issues with this differential. Now we'll get to taking this apart. As you can kind of tell, this one's the 12 and then on either side is a 1/2 inch. So we're gonna break these loose. I did need a wrench for this one because this collar is seized into here. This is for your PPF or your power plant frame to mount into this. So if you have that issue, you will need to use a wrench to get at this nut or bolt right inside of here. Once you got all the bolts loosened up around the front side of your differential, you can now try and split it apart. Now, I would recommend trying to split it apart with your chisel on the top side of the differential. If you do scratch that aluminum housing, you're less likely to have a leak on the top side than you would if you tried to split it apart on the bottom. So we're not gonna use the chisel right away. We're gonna try and just hammer on it a little bit with a dead blow and see if we can get this thing to pop apart. You typically wouldn't want to slam on the wishbones of this differential or the aluminum housing. However, I have 1/4 inch aluminum plate welded on this. It should be pretty sturdy and it shouldn't have any issues with it possibly cracking. So we're gonna give it a couple of swings, see if it'll pop apart. If it doesn't, we'll move on to the chisel. Now the diff is split into two pieces. It's pretty simple. Now all we have to do to be able to put this back together in a minute is clean the mounting surface or the mating surface of the aluminum housing to the iron portion right there. Clean it up best you can, make sure there's no oil on it, make sure all the old silicone is cleaned off of there, and then when we go to put it back on, we'll put silicone on it, smear it around a little bit, leave that sit for like 5 or 10 minutes. It's kind of cold out here. Give silicone plenty of time to start curing before you try and smash it on. So this differential, or the gear ratio in this open diff, is a 3.9 or a 3.91, can't remember exactly, but it's in that 390 range. So what that means is there's a certain amount of revolutions of your drive shaft per rotation of the tire. There's 3.9 revolutions of the drive shaft to make 1 revolution of your tires. I think I have that the right way. Maybe it's backwards. I'm pretty sure that's right. If it's wrong, or if it is right, drop a comment down below, let me know. So what we're looking for in this inspection is, are any of the welds on the spider gears inside cracking with that plate in there? Because the plate is dropped into like a square or a small rectangle in there and then welded all the way around the 4 sides of the gears. We're going to take a look at that real quick, make sure there's no cracking or major fatigue on both sides. There's this one, and then you spin it around to the other side, and it is also plated with the same size piece of material so that it was hopefully balanced inside the diff. We're also going to kind of check if there's any play in the pinion to the main ring gear. I checked it already, it doesn't seem like there is. We're basically just going to hold on to this gear and try and turn where the drive shaft would be, and there's no play there. It's nice. It's not like super snug because there should be a little bit of clearance so that it's not wearing funny on this main ring gear or the pinion. All right, so what we're looking at here, kind of what I was talking about just a second ago, is basically all 4 sides of this weld on this plate. We want to make sure it looks like it's all still intact, that there's not any big cracks or anything. From what I can kind of tell, everything looks like it's pretty solid all the way down into the corners inside here. We'll spin it over to the other side. And when we look at this side, everything all the way around is solid, all the way into the corners still. No fatigue, no stress fractures or cracks or anything. Looks pretty good for 3 years of being basically beat on the drift track. So yeah, looks pretty good. Now the next thing that I'm going to be looking at is basically in between each of these teeth, making sure there's not like metal shavings or glitter or anything that looks like abnormal wear. So when it's driving, I want to say it goes this direction. No, it goes this way, because it's pushing on this face to turn it around. Now, everything that I'm seeing looks like it's really good. There's no issues or cracks or metal breaking apart. If you would start seeing something like that, you'd want to maybe double check, make sure your bearing clearances are good, that it's not too tight. You know, you don't want your main ring gear pushing too much into your pinion gear down on the bottom. That's way inside in here. You guys can't see that from that angle. I'll show you that in just a minute. Everything looks to be in okay condition. There's no weird abnormal wear. I also change the diff fluid at least once a season, if not 2. I think last year, 2024, I switched it twice, and I threw some royal purple in here. That stuff kind of stinks, but I mean, I tell you what, it is nice and lubricated in here. Don't buy just a bunch of cheap stuff. Buy something that's gonna last. Now I don't know if you'll actually be able to see down in there real well, but that's where the pinion gear is. The drive shaft is connected to that via the front side with these 4 bolts. And then as you spin it, it spins the main ring gear, which then rotates your CV axles coming out either side. So that looks good and healthy down in there as well. No weird markings or anything in between the teeth. So I'd say this thing is in real good condition for being welded for 3 years. Next step of the process is get both of those mating surfaces cleaned up real nice and well. Make sure all the oil and silicone is cleaned off. Then we can get that silicone on there and then get those two pieces pressed back together. I got this all cleaned up. It's nice and dry. No excess amounts of silicone or oil on the aluminum case or the cast iron case. So we want to make sure you get all the way around this lip so it's nice and clean. Any like imperfections of silicone or anything like that, make sure you get that kind of buffed out. And we're going to take our silicone. You could either put it onto the cast piece, the iron piece here, or the aluminum. Either one, it doesn't really matter. You don't need to put it on both. It's going to end up being way too much, and then it's going to either squish up and potentially get into your bearings here or drop into your case, which you can change the fluid after so long and you'll see silicone come out. Whichever you prefer. I'm just gonna go the easier route and go on the aluminum case here. We're just gonna smear a nice little layer. Make sure you get inside and around the edge of the bolt hole on, you know, the gear side, not just on the outside. Make sure you get a nice little smear around all the bolt holes. You don't need to get it into the bolt holes. I had to sit and scrape some of it out of them because that can just pressurize and it'll back your threads or back the bolts out of your threads, and you don't want that to happen. So get a nice little smear here, and then we will get this dropped right onto the differential there. Now that I have silicone smeared all over my fingers, take a look at this real quick. Now I went through with a light coat and made sure there was a nice even coat all the way around first. Then I came back and I actually took my finger on the outside edge and kind of built up a little bit of a ring right on the outside edge. It's gonna be really hard to kind of capture that, but just a little bit extra right on the edge to create like an extra ring of silicone. We're gonna let that sit and cure for a few minutes, and then we're gonna drop it onto the actual front portion of the diff. Now I don't have like a super great way of like supporting this. I just have this big block here to kind of help stabilize it a little bit. Make sure you have it positioned the correct direction. So the top is up here, so the wishbone has to go up on this side. I don't think you can mistake that because there's like 3 holes that are side by side right here that are right here. You can only put this diff together one way. It's not going to work the other way around. So I cleaned out the aluminum shell the best I could of oil so that there's not going to be a bunch running down and making a mess all over the silicone, because you want that to seal. You don't want that to leak later on. Otherwise you're just going to have to take it apart and reseal it later, and that's a whole process, taking it out of the car and resealing that diff. We should be able to just flip this around and drop it on. If it doesn't want to go on right away, like first shot, you shouldn't have to hammer it on. You shouldn't have to like bang on it. Maybe just with your hand to get it to drop down, because there's like a seam and a lip right here that this should seal really nice onto. So get this flipped into position. Do this kind of quick. Now the only problem is I have this technically upside down to be able to get the bolts in it. So we got that set on there. We're just gonna leave it sit kind of. Hopefully I have them bolt holes lined up. I don't want to sit there and spin it around a bunch. We'll try and flip this without it dropping apart. Then the weight of the gear will actually kind of seal itself on there. Yeah, I do have the bolt holes pretty good. Now I just have to kind of support it on my own, because there's not a real great way of holding this. Make sure them holes is lined up. Now you have a couple of bolts that can only go in a specific area. So you got this longer one, it can only go in this one spot on the bottom, and then this little bit longer one can only go right there. Everything else is like an 1.25 inch bolt that can go basically wherever hole is open. We're just gonna kind of snug these up with my small little impact. It only goes like 35 foot-pounds. We're not gonna sit there and chug on it. Just get it snug to where we can leave it sit and cure for another 5 minutes or so, and then we'll actually tighten it down by hand, not with an impact, just so that we don't over tighten it, because the threads are in aluminum. You don't want to over tighten that. You'll just literally rip your threads out of the case, and then you're kind of out of luck. You have to get an entire diff and to replace that. So don't hit it with an impact. That's not gonna end well. All right, well, the diff is all sealed up. I got all those bolts re-tightened up. I only use a 3/8 drive ratchet to tighten those up. Again, you are putting a steel bolt into an aluminum threaded casing. Don't over tighten those or you'll be looking at a lot of trouble and a lot of bad times, okay? Now I went ahead, slammed the bushings into the upper control arms. They are all taken care of, ready to go in the car. We're not gonna put these in just yet because we need the diff in there, and then we need to pop the CV axles into the diff before we go ahead and slap this on, and then the knuckle onto the CV axle and the upper control arms. So we're gonna crawl under there real quick and slam that into the car as well, get this all wrapped up. Now that the diff is in the car, we are going to install the traction bars or the torque bars for the rear subframe. This ties into the front or towards the middle of the car almost. It basically just prevents the subframe from twisting or bending or doing any weird stuff. It just ties it into the chassis. That step is now complete. I got those bars in there. I just threw them in there. It's kind of tight to get in there with the camera. And now we got those bars. I go forward and tie the rest of the subframe up to the rear portion of the frame rails there. Now we can put those upper control arms into the car along with the CV axles and the knuckles. Once all of that is basically in place, then we're gonna weld those bars to the subframe like I was talking about. So I just got the bolts and the control arm up in here, and I am really excited to see how this car feels. This is so much tighter back here than it was before with the old bushings. Before you could kind of grab the knuckle and wiggle it and you would get movement out of the bushings. Now there isn't even a millimeter of wiggle in this whole setup down here. This is gonna be way different than before. It's gonna feel way more precise. I think any type of inputs with the clutch and the braking is gonna be spot on point. This is gonna be way better for this year. You probably won't be able to see it on camera because obviously it's not really moving. Now, I don't even have the bolts tight because we need to put the jack under here and give it a little bit of preload on them bushings before we ram everything tight. But I'm trying to push on it and it doesn't budge or move at all. That is gonna be so good for driving this year. That being said, I'm gonna throw the jack under this side, get everything preloaded with the bushings with tension on it, so it's like the car is sitting on it before you tighten it down, and then get all this side tight, get the control arm and the knuckle on the other side, and then we'll get to welding those bars real quick and kind of finish up the assembly process of the rear end. Then we have to jump into getting the drive shaft back in, the PPF or power plant frame, and then get all of the rest of the little wiring stuff taken care of, get the brake rotors and brake calipers back in, and then it's almost ready to set on the ground. Then we'll take a look at what the ride height is. I lowered it about a 1/2 inch according to what's on the coilover. That translates different once you actually set it on the ground. It could have moved maybe 3/4 or an inch lower than it was before. Now, if you've seen my car in the past, I do have it raised up quite a bit, and that's so that the control arms in the back are completely level with the ground before you get on throttle. And then once you accelerate, of course, it should squat and then that position changes. It just helps with roll center and everything like that. We're gonna change it up a little bit because I used to have it dropped a little bit lower in the back so that the weight transfers harder on the back and gives it a lot more bite and dig in the corner. We're gonna go back to that and see what it does this year. Moving on to the next step, we're going to weld on those bars underneath. I got everything tightened up, everything preloaded, and I got the brake rotors and calipers back onto the car. Everyone's kind of seen me do brakes before or seen someone do brakes. Pretty simple, rotor, caliper, 2 bolts. Really simple on the Miata. So everything now is tight. Everything is complete under here. I actually already threw the wheels and tires on there and tightened the lug nuts all the way down before realizing, dang, I need to take this back apart and weld those bars on, because if they're not welded together, they're not doing anything. So, took it all apart. Now we'll get those bars right in there, welded back up, right in that spot. Now, I don't have any leftover purple, which I probably should have saved a little bit for spraying over where I'm going to be welding. Whoops, that's my bad. I still have teal and antique copper. I don't know if I want to spray over that with that, but if I do, it would probably be the teal, and there would just be a little ring right around where the weld is. Not that big of a deal. Get this lined up. Give her a little tack. Hopefully it actually grounds through the whole subframe from on that side. Yep. Need a little more wire. Now that that's welded, we'll give that some time to cool down before we try and spray a little bit of paint over that. Just enough to cover it so that it's not gonna rust, being out in the elements. Just rain and water and mud can make that rust and oxidize. So make sure you get any welds sealed up. Damn, that is stiff. Oof, yeah. Okay. Yeah, that used to move a lot more than that. Ride height's pretty good. I think we can actually leave it right there. Yeah. Rather than having 3 fingers on top of the tire, now there's 2. I mean, that took some height out of it. We'll probably leave it like that, even with the front jacked up like that, because that's just going to add a little more jacking onto the back and a lot more forward grip and side bite in the corners. I think that should work really well. And then when we end up doing some more work on the front end and getting that front sway bar in there, I'm hoping I can get this car to start 3-wheeling this year. If you're not familiar with that, go check out some like Formula Drift, some of them pro cars, where you get really high angle into a corner. Their chasing front tire will actually lift up off the ground because they have so much torque and twist onto that leading drive tire. That's what I want for this car. I want this thing to dig really hard. The entire rear end and subframe refresh is now complete. Everything in the back is all reassembled, rebuttoned up, all nice and tight. I am super excited to see what this car is going to be able to perform like with fresh bushings and everything refreshed in the back. This should hopefully make the back end of the car feel nice and tight and do exactly what I want it to on the track. I just had my wife come out here real quick and help me check the alignment on the back, or at least just the toe. Before I did all the bushings and did all this work, the toe in was a total of 1/4 of an inch. It is now 3/8 of an inch. So tightening up all the bushings, making sure everything is nice and snug and getting all the preload proper and correct, it actually towed it in an extra 1/8 of an inch from what I had it. So that's gonna make the car perform better, just being that it's tightening everything up and it's actually pulling everything forward to where it's going to have more forward bite. I know that dropping it down is going to add a little bit more camber back into it, which is actually okay if I was, positive 1/8 of an inch. If it actually zeroes that out, that might actually help the car as well, because it wasn't squatting as well as I wanted it to. So I was actually staying in that positive position, or actually like rolling the outside edge of the tire in, and I was using more of the shoulder of the tire than I want to. So the tire life wasn't actually super great. So I'll maybe check that real quick and then let you guys know. I had it zeroed out before, or like an 1/8 of an inch positive. Now it's actually negative 1/4 inch of camber, which in degrees, that might be a 1/2 degree, maybe 1 degree of negative camber, which is totally fine. That's okay. That might actually help with my side bite as well. Rather than riding on the sidewall or the shoulder of the tire, it's actually gonna be planting on that outside set of lugs around the tire. That being said, that's gonna wrap up today's video. If you like this video, smash that like button. Don't forget to comment and subscribe. Thanks for watching. Stay tuned for the next one.